All right, here we go. Now office hours are being recorded. So we have at least two main topics for today. First of all, the thesis topic. So Vladislav, as he already said, contacted all of you. I hope now everything is a bit more clear. And second, the change of the base chair. You were previously assigned to the discrete mathematics base chair. Now you're actually being switched to the machine learning base chair. Actually, machine learning and digital humanity, something like that. In English, at least it sounds kind of fine. In Russian, it sounds kind of really strange, but it happened. So the base chair is just named this way. So we have to deal with it. So only thing I ask you is just to first sign the papers you got on the email, and then send the signed version to the original email you got it from, and to send the copy to our organizational email. I send it to the chat. Right now it's MSAI at MIPTRU. So I want just us to have all the copies in case there are some problems, maybe wrong dates, wrong something. So to aggregate all the information in one place. All right, if you already send it to the Dean mail, then please resend it to this email as well. All right.
And Paulina asked a question about the name of our program, something like should we write combinatorics or MSAI?
I checked it in the Dean office as well. So the idea was the following. There is the educational program, which is named MSAI, and there is some kind of more general structure, which was just inherited from the applied combinatorics just because applied combinatorics was created first. So it's fine that it's written that way. In the diploma, you still will be just masters of applied mathematics and informatics, and all the subjects will be from MSAI. It just sums their inner structure from the paperwork. So just depends on the some paper stuff. It won't affect diplomas or anything.
It means we should follow the instructions and the template.
Yeah.
Okay.
Yeah, I checked it, so it should be fine. Actually, if there is any problem, we still have plenty of time, so I will just be able to fix it if something comes out later. But this Friday, I checked it at MIPT, and everything should be fine.
Okay, thank you.
All right. Any more questions on that? I mean, about the change of the base chair. All right, then I guess I will switch word to Vladislav, because today we also need to discuss the thesis. Some of you have already started, some of you have already written some stuff. We're in contact with you as well. Actually, we need to make one more iteration, but some of you still are struggling to find the thesis advisor or specific topic you're interested in. So actually, it's time. And we're here just to clarify what you can do right now, what we can do right now, and which topics are still possible if you don't have propositions like the one Andrei, for example, sent about the robotic arms, because robotic arms are rather informative and interesting stuff.
I think let's introduce it from the start. Yeah. Okay.
Yeah. So here you go.
Yeah. The basics about your thesis is first, it is obligatory work that you have to do to receive the final diploma. So this is your work, your own kind of creativity on the one hand, and on the other hand, you show your technical level, your ability to solve problem kind of end to end from formulation up to final solution and presenting this solution to the public finally. This is the first, it is obligatory work. The second one is that finding interesting and maybe fascinating work for you is your responsibility. During our courses, you already seen some topics, maybe some stuff something you worked on in your previous work experience or something. So, I mean, you have your interests, maybe something. So, and I think that is the point. You could formulate maybe a couple of things that you like, couple of things that you are interested in, just maybe some abstract point like making chatbots or making robotic arms in any ways, or I don't know, maybe detecting people by voice, like identification or anything. And if you do that, that is the starting point. If you don't know what to do, start with it. The second thing is to find your thesis advisor. The first thing here to try is our document that we already published with some topics, and some of you already have these topics. For example, myself, I get now four people from the program, and I think we already started our work, and it's really nice results we have already done. Maybe you've seen talk from Dmitry Korshunov. He told about depth estimation. This is his topic. For example, Karen works on BCI, and we already created the repository. We push some code there and so on. So the work is in progress. And in this list, we still have some topics. Please read them carefully. And maybe if you are interested, write to the person and to the person who suggested this topic. And please don't hesitate. The earlier you start, at least some discussion, maybe some agreement with the thesis advisor, the better is for you. And yeah, still it is your responsibility, but if you hesitate a lot and you will just go up to the points that we don't want you to reach, we will give you some default thesis advisor with some default topic, but that's not the case that we want to go into. Yeah, as I said, the first point is to create your own topics that you are interested in. I think that is the best way. And we will ask you for these topics in some time. And if you could not find someone to suggest you, to advise you, we will maybe try to find someone. But basically, besides the list that I mentioned already, you have our teachers. So all the teachers from our courses are available. You definitely should write them if your topics are connected with their work. For example, I think robotics hands could be described by Oleg Shepetko. He's online. I think, Andrei, you could write him, and he definitely knows some chats on robotics, even in Moscow. So you could visit it in person and ask someone, or just maybe some Slack channels and so on and so forth. So if your topics is connected to some of our courses, the best way is to ask the course author to help you reach some people that are interested in this topic. Yeah, this is basic actions from you. And please don't hesitate. As I mentioned before, we expect you to, like, it's 12th of November, 20th of November now, and we expect you to have topic advisor by maybe middle of December. I think that is,
I would say even by the end of November, because
yeah, okay. So I mean, from this point on, it is bad situations that we don't want to go to. Okay, so I think that's all. And one more time, takeaways: first, obligatory work; second, your responsibility; third, the top list of topics you're interested in; and fourth, people, thesis advisors, which could be taken from the list or from our courses, lecturers, authors, teachers. And if you done these things, then you go to us, to me, and to Radoslav, and write something like, "Hello, I don't have any topic advisor. Anyone I asked decline me," and so on and so forth. In this case, we will do something, but before that, we require you to do something yourself. If you don't do that, we can't. We cannot help you. Okay.
We'll try, but it's not guaranteed.
Yeah, I mean, if you do something, we could do something for you. If you don't do something, then our power is very limited.
Okay. So any questions on this particular part? So we discussed what was the first topic?
Chair change.
Yeah, base chair change, then thesis advisor and thesis topics. And just don't worry, if you already started, then everything's fine. You should be just in contact with your thesis advisor. There will be only one actually additional change that we will ask you to give you and your thesis advisor as well, to give some updates using the general form every 2 weeks. So we actually can see that something is going on and nobody is lost, because sometimes people might be lost somewhere or something might happen because, I don't know, somebody is going to vacation, something. Actually, here we have Ilya Makarov.
I just will add a bit about this topic and then introduce Ilya. And I think we will commit an event on kind of pre-defense on thesis topics on maybe February. Somewhere in February, we will present topics to ourselves. So I think this will be an event. You won't have any courses in the last term. That's why by some time,
any obligatory courses,
obligatory courses. That's why we will have some events that are required to visit, where we will present all our work to each other. I think the first event will take place somewhere in February, maybe at the first decade or something like that. So the start of the term, and there you will present your topics. So it will be 10 minutes talk for everyone or something like that. We will provide more detailed information with 5 to 10 slides where you present your choice of the topic. So it is really topics that need some kind of research or some work, that it is related to real life, how you will maybe use it or something. And by the way, you will know topics of each other, and you could, for example, collaborate on these things and so on and so forth. I think we will have maybe 3 to 4 such events. And the final event is thesis defense. It will be, I guess, will it be June, Radoslav? I'm not sure. Or maybe start of July. Defense.
Defense should be somewhere in July, I would say. So the exact date, I guess, won't be available till the at least middle of spring, because it just depends on the global processes at MIPT. But usually it's really before the beginning of July. Usually it's somewhere between first and second weeks.
So it is basically July. I think from this point it's enough. Yeah, and that is all. And then I told about our document, and there we have Ilya. I think all of you know him. Hello.
Okay.
So he's here to present his topics and an opportunity to work with him on some projects. Then I think the word goes to him.
Yeah, thank you very much. If you also allow me to share screen, it will be good.
Sure, one moment.
So basically, let me again, like for those of you who did not attend for Graph Machine Learning course, I will just briefly introduce. So my name is Ilya Makarov. I'm lecturer at High School of Economics and also at MIT at the Department of Programming Technologies. So basically, we have several topics related to, one or more of my jobs, and basically I'll just cover them in a brief manner. Most of these topics require working eyes on some prototypes or topics that are under some contracts with the companies, or mostly they're devoted to research. So basically, all of them require knowledge in neural networks, not only graph neural networks, but in general for computer vision, for NLP tasks. And in some cases, of course, it would be good if you have, some preliminary experience of writing your research works or course projects in the format of draft for research papers, because basically the main goal of any research is to get published, not just finish some text and place it in the table or upload to some learning management system. So I will start with very short descriptions of each topic. And again, if you have questions, you may ask me now, or of course you may write me just personal message in Telegram, or Daslav or Vladislav will show you my contacts. So basically, one of the first topics and the most interesting for me is supervised or self-supervised learning for depth estimation. So this topic covers different settings for depth estimation task, which is standard computer vision task. You have either GB or sparse depths from some low resolution depth sensors, or you may have noisy depth predictions from LiDAR or from some time of flight sensors. You have high resolution GB camera, you need to restore dense depth maps, and this kind of applications have various uses in self-driving cars and in augmented reality. For the self-supervised setting, is usually it's like when you don't have enough of labeled data, or it may be affected by different sensors, different calibrating schemes. You may use additional tasks to supervise or regularize your predictions and just train depth estimation without supervised labels, or later fine-tune them to provide more robust domain adaptation for different data. So the second topic about graph machine learning. So basically, it's like you have a lot of applications for recommender system. Let's build new architectures for graph neural networks, for temporal graph machine learning, for static graph machine learning, and everything related to these topics is of interest. And those of you who listen to the course, you already know some directions for research here. Then topic of industrial machine learning, that's pretty much close to my work in Artificial Intelligence Research Institute in Moscow, Russia. So we do a lot of study on anomaly detection and fault prediction based on multivariate sensor data. Also, we study such problems such as change point detection and health index building based on remaining useful life estimation for industrial equipment. So in this case, you work with multivariate time series, develop some dimension reduction techniques for noisy data, and then try to solve either supervised or semi-supervised or unsupervised tasks related to monitoring and predicting maintenance for industrial equipment or chemical process which are related to it. Then we have topic on semantic aware gun manipulation. So you may know that you could build a gun for generating faces, for example, but having some generated image, there are some options how you could change just one semantic, such as, for example, changing color of eyes, changing color of hairs, type of hair, rotation of head, and so on. So it's pretty interesting to see how supervised and unsupervised methods for finding semantically meaningful directions in the latent space of GANs can be found and applied for different tasks, starting from computer vision. We have some application, for example, for comics colorization or manga colorization, and ending also in industrial ML when you have when you could find some directions on the lattice space of manifolds that leads to anomaly cases deviated from normal behavior. Also, it's quite interesting to search for new architectures such as normalizing flow or diffusion models for interpretable health indexes. Next topic is mostly related to our partners from Huawei, and so maybe of great interest for them. It's AutoML and neural architecture search. So it's pretty much the most famous case is image classification, for which one could find not only chain architecture, but branch architecture for better, robust, and resource-constrained image classification on device. So in these cases, you need to find efficient top 1, top 5 state-of-the-art accuracy networks for which you have some latency constraint measured on device. And there are also various task types. For example, could we build some zero-shot or few-shot learning methods without need of retraining sample networks? And also whether it is possible to apply methods for neural architecture search in dense prediction tasks such as super resolution and depth estimation. So could you do AutoML for dense predictions? Then you have some applications for vision transformers for video and also for sequential data. So as you may know, it's current state-of-the-art architectures supporting global consistency in many computer vision tasks. So that's pretty much about training big models that could provide state-of-the-art in many standard computer vision problems such as segmentation, super resolution, depth estimation, object detection, and so on. Next, I have two topics related to knowledge graph. So one of them is knowledge graph embeddings and retrieval from text. So that's a general topic and general direction, which is of great interest, how to build linked data from text, maybe different languages, and also how you could build argument mining after constructing knowledge graph from text. And each of the sentences or each of the facts belongs to some subject who says this, and they may have some conflicts of interest, how to build a system that could measure this. And we do this research based on documents on Chernobyl disaster. Next NLP topic is also about authorship style learning via few short text samples. So that's pretty much connected for the problem of authorship of well-known case of Tikhidon, which is said to be written by Mikhail Sholokhov, but there are a lot of concerns regarding other possible authors from which the text was taken and rewritten by Soviet writers. So in this case, it's interesting to see whether it's possible to do verified computer science methods that could identify authorship or mixed styles of authors and try to suggest some statistically significant results on the authorship for this particular case. Then we have also a lot of topics about deep reinforcement learning in games industry and recommendations. So you could start with multi-arm bandits in online recommendations to make more clear and more personalized recommendation, and also study deep reinforcement learning for Wisdom or Match 3 games. We also may have some topics from Sber Games company that's also developed a lot of interesting things, how you could add bots into games that play like human, and so on. Finally, we have some applications of computer science methods. So one of them is COVID-related problems. There are various topics such as antigen antibody connections to predict some beta updates of vaccine or predict immunity of a person. And we also have some topic for time series analysis, how you could predict quarantine measures and how they will affect overall spread of COVID epidemics. Regarding graph neural networks, we have applications to chemical reaction modeling. So try to go to chemistry and physics. So for example, in physics, we also have something like Open Catalyst project in which you could participate and predict how new materials will behave and could be described based on first order principles and just atom level, molecular level physics, and how graph neural networks could improve baselines. So that's pretty much a famous challenge from Facebook Fair and Carnegie Mellon University. And finally, there are quite, I would say, quite general topics such as quantum ML. Let's do some survey related that topics related to brain-computer interfaces and transfer learning for AG. which could be made in conjunction with the Institute of Neurosciences at HSC, and also study new neural networks such as capsule networks, spike networks, neuromorph computations, brain-inspired architectures, and so on. And that's quite interesting startup about audio to text unsupervised translation for building something like chatbot or voice chatbot for animals or babies. So of course you couldn't translate exactly what they're speaking, but at least, I mean, it could be fun applications if your dog could talk with you in some way. So there are international startups who are doing this kind of thing, and I can say it's quite interesting topic to just launch a spin-off. So basically, there is a link on my pages in LinkedIn and Google Scholar where you could read my papers, and in general, it's like overall format that you need to write research article in English, you need regular updates and work in an overleaf. And especially you need some deep learning experience that will help you to start working on stuff. So I have finished. I can see that it takes about 10 minutes. So I was trying to be short, and I'm ready to answer questions.
Ilya, I have a question about reinforcement learning in industry. Can you provide more details, and does it include robo arms, for example?
Well, yeah, so basically it's like we don't have some kind of facility to test robo arms, but of course we could take these topics. And in this particular case, it's quite interesting to either start with few-shot learning methods for robo arm manipulation, or studying some kind of hierarchical skills where a deep reinforcement learning could learn skills as a consequence of well, approximately learned skills of manipulations and so on. So I would say that there are some recent paper by Jan LeCun and Joshua Benja, I mean, famous deep learning pioneers, that study this kind of problems, and it's like we could try to see, at least in simulation, what can be done in this direction. But I mean, the only applications that I don't have, I mean, the robots that could be tested in practice for this topic.
And some real world robot, for example, from real materials, not in simulation.
Yeah, I mean, it's like I don't have this robot. I mean, we could build, of course, Lego, I mean, or the one of these robots if it's not too expensive. But I mean, as of now, it's just simulation-related task. And you know, it's like the problem is that even if you buy this robot, I mean, it's hard to say that it will be applicable for some company or for some factory, for example. And it's like if they already buy some robots, they may not have API for them. So it's really hard to match hardware, I mean, exact hardware that will be stored in your laboratory and data science that need to be first made to proceed with buying robots and trying to show some MVP or real world applications.
Okay, thanks.
Okay, other questions? So basically, I mean, if no questions, again, you could ask me. So let me just place my contacts here, so it will be much simpler. It will be much simpler to get in touch. And just in case, I mean, if you don't understand anything or miss something, you could at least work on my already published papers and go to Google Scholar and see what's going on and what can be done. Mm-hmm. Yeah, thank you for questions. Thanks for comment in chat. So Radoslav, I'm finished.
Yeah, thank you.
Ilya. Thank you, Ilya. It was really great, and we're glad you're here with us to guide students as well. The problems are really interesting.
I guess some students get interested after this presentation. Yeah,
I already see some. So it's great. Actually, so yeah, it was the second and main topic of today's discussion during the office hours. So once again, you now see a bunch of really great problems and really great thesis advisor, Ilya. I had a chance working with Ilya before, so really recommend you interacting more. And just to clarify, we still here to help you find the thesis advisor, but as Vladislav said several times, we need your just activity. We need your initiative to start with it, because otherwise we will just give you some topic and say, all right, you work on this. And that's not the best way to select the master's thesis topic, because if you're not motivated to work on it, then usually it's not so good. So it should be coming from you as well. All right, actually for today, we have only the third topic we need to discuss, and we have time to answer any of your questions which can be answered. Actually, it's the time borders of the semester. So I've just clarified some borders, and I can share it right now almost for sure. So the exams will take place in February. And before that, in January, you will have some time to prepare for the exams, to take some New Year's Eve vacation, and for some maybe additional discussion on several topics. So we can say that we have, for example, first 2 weeks of January fully free of any kind of mandatory interaction. And the second part of the January, we can have some additional webinars, discussions, and so on. They will be recorded as well. So they're not mandatory, but they're highly useful if you will join them. And the exams will be in February. So in February, especially in first 2 weeks, we require you to take part in the exams. All right?
Vladislav, does that mean that all lectures should over by the end of December?
Kinda not so sure, because all the mandatory part of the program will be actually over by the end of December, or maybe just available at the beginning of January, so you can still watch it during the January. But we'll have, I guess, several additional lectures, so you can dive deeper into the material, but it will be more like extra overview of all the areas, so it will be optional on the exam. We hope that you will be actually able to dive deeper in it, but if you don't have time, for example, right now, we'll just provide you opportunity to dive deeper. So it's kind of balanced, because we have a lot to share, and we still have a bit strict limitations on the program structure from the MAPT side. So maybe we'll even have some additional classes during the spring, but they will be mostly about some extra stuff.
You also said a few words about possible non-obligatory materials in the fourth semester.
Yeah.
Do you have any already available thoughts?
So speaking about the fourth semester, first of all, there will be the courses from all other programs, because they always are available to you. And in addition, there will be some updated courses from us, which will be shared. I will just share the list of them when they're at least, I don't know, 75% ready. So they will be held for sure. So you will be able to join them as well. But while they're only in process of creation, I won't share any details, so you're just not disappointed that they didn't start. So right now there will be some additional courses, I guess. So when they're ready, we'll share them.
Can I ask you about additional courses, maybe about graph machine learning? Is it about the second part of it? Will we have opportunity to join some additional course?
Actually, great question. Actually, I can forward this question to Ilya. Actually, he was originally author of this graph machine learning. So I have an intention to update the course to make it whole semester, but it depends actually on several situations. First of all, on the time of lecture, I actually can capture this course by myself if there are no just restrictions to update the materials and just to inherit from them. And so it's an open question right now, but I guess at some moment we'll definitely have one whole semester of graph machine learning, maybe not this year, because it's really huge labor to create it.
Yeah, I mean, it's like it's saying thank you for the question. I mean, that's pretty much, I mean, direct question. So Vladislav, give me the course with this guy. Yeah, I like this kind of situation. So basically, we are doing extension of graph neural network course in Big Data Academy Mate, and basically in this autumn we test it out. So we just prepare materials, and I mean, I'm certainly not ready to launch second part in this semester, but maybe starting from January, yeah, it's like if it fits the program and there are some places for lectures and classes and you still have the opportunity, yeah, we may do this. And also, I mean, we could extend basic courses on introduction to network science and graph machine learning. So it's like if we have time to discuss it in advance and it fits those program criteria, so yeah, we could do this. So it's like all the materials are basically the same. So we have some video lectures, we have some grading system, and I mean, there is no problem to launch also course on your program. So it just, I would say that extension of graph machine learning course will be, I mean, at some point it will be much simpler because it will not have the same every week labs. But on the other hand, it requires some prerequisites that you need to listen to the previous course because otherwise you will not understand anything. So I mean, that's pretty much some advanced topics, and we have also some good courses which is read by Yuri Leskovets at Stanford, which is called Graph Neural Networks. So it's open, at least regarding PDF of lectures and some homeworks. And I can say that's like we are doing much more advanced course compared to this. I mean, with regard to materials, but they're quite good starting point when you want to dive into details. And I mean, we are more or less overview existing papers and give the main ideas of what can be done in graph neural networks. And in their course, they dive into details of why, I mean, some particular architecture works. And what's more interesting is that many of the architectures are just made by the author, so by the lecturer. And it's always, I mean, a difference when you build a course which is made from your papers and all of them are used in practice. So it's also one of possible recommendations where you could get knowledge right now. So they have currently launched the course. I will send you the link in chat as well.
Thank you. Yeah, just a tiny addition from myself. This course from Yuri Leskovets, actually, I watched it back in 2019. I guess it was really a good introduction to the topic. So in general, if you're just interested, it's always a good addition. So I would recommend it from myself as well. Just all the lectures are actually available online on YouTube or on some FTP server. I'm not sure whether they should be actually open worldwide, but still they were open at some moment. Any more questions?
Yeah, I could assure myself that this course is really, really nice. Definitely worth to see it.
Yeah, and actually, a beautiful part is that once again it gives you some introduction as well. So if you feel lost, then you can start from there. Okay. So, any more questions? Anyone? So today we captured 3 actual topics, and they, I guess, the main mandatory topics that need to be discussed. So if there are no questions right now, I suggest we start the recording and upload this part for everyone. So everybody who is online, thank you for joining us today. And the recording is